This is Physics 1 course. In this video, I'm going to derive an expression for position and acceleration vectors in polar coordinate system. From previous videos, remember that we had a position vector r equal to its x component I hat plus y component j hat. So if I had this projection from here to here was x, and then this projection from here to here was y. So y was here, x was here. Now in polar coordinate system I have r, the magnitude, which is from here to here, r hat. So r hat is a unit vector in this direction, in the direction of r. We call it r hat. And now normal or orthogonal to that r hat, I can define another unit vector and call that theta hat. And if this is theta, which is usually defined from x-axis, then theta hat is in the direction of increasing theta. Now the velocity vector was v equal dr divided by dt. And since I hat and j hat did not change with time, because it was always in the same direction, it was easy in Cartesian coordinate system to take derivative of the r vector. So it was just the derivative of the x component and the derivative of the y component. Now let's go and take a derivative of the other side. So it should be equal to dr dt r hat, but this time r hat is also a function of time, and I show you why in a moment. So let's for now write the exact equation. So the reason r hat changes with time is that if, for example, particle or the object moves in this system and goes somewhere, after some time it goes like here. So this is now r2 position vector. Then r hat has to always be in that direction. So the direction has now changed. Now if I, after some other time, r3 is the position of the vector at some later time, then this will be r hat. Therefore, the polar coordinate system is not as easy as Cartesian to work with, but it is very convenient to use when we are going to solve problems that involve like circular motion. In the following, I'm going to find two simple expressions for r hat and theta hat, and if you memorize those two, then you can always solve problems in polar coordinate system quite very easily. R hat is basically a position vector with r being equal to 1. So if for a special position vector r was equal to 1, then r and r hat are equal, right? So therefore I need to find x and y for that r equal 1. So let's first find x under r equal 1 condition. It's basically cosine theta. Why? Because cosine theta is this length, which is x, divided by the magnitude of r, which is 1. Therefore it's just x. And then y is divided by r, which is already equal to 1. It's just sine theta. From these two I can say r hat is equal to x I hat, so cosine theta I hat plus sine theta j hat. To find theta hat, let's draw r hat and theta hat one more time. So this was r hat. Let's say this is r hat. So I just moved this thing all the way down here, because I can always move vectors around as far as I keep the magnitude and the direction. Theta hat, I bring theta hat to the, I draw it from the center. So this is the theta hat. Now, see, this is theta. Let's say this is alpha. And I know alpha plus theta is equal to 90 degrees. Now, theta hat and r hat are orthogonal. Therefore, this has to be theta, because then theta and alpha become 90 degrees. So now, using that, I can write theta hat. Theta hat is equal to minus sine theta minus sine theta I hat. The minus sign is because it has a negative x component, and plus cosine theta j hat. If you memorize this, then you can always calculate a v quite easily. Now, v is dr dt r hat plus r dr dt. So I need to calculate dr hat dt, and that's equal to, let's take a derivative of that, knowing that theta is a function of time, just like r, that is a function of time, because the position changes, therefore the r and theta both change as function of time. So therefore I need to take a time derivative of cosine theta. So it's minus theta dot sine theta, and I hat does not change with time, so therefore there is no derivative on I hat, plus theta hat, or theta dot, that means time derivative of theta, cosine theta, and j hat. Now if you compare this and theta hat, you'll see that it's simply equal to theta dot theta hat. Therefore, the velocity vector is, so this is r dot, velocity vector equals r dot, and this is r hat, so r hat plus r, and dr hat dt is equal to theta dot and theta hat, theta dot theta hat. I recommend you to simply memorize this equation for later use rather than deriving it every time. So now let's find A, the acceleration vector. So dv dt equals, now I need to take a derivative of this expression. So it's r double dot r hat plus r dot dr hat over dt plus, now I'm done with this expression. Now r dot theta hat plus r theta double dot theta hat plus r theta dot d theta hat dt. So for dr hat dt we already have an expression, theta dot theta hat. So this thing here is simply theta dot theta hat. But how about this? Let's calculate it. V theta dot dt equals, so now simply take a use of that equation. So it's minus theta dot cosine theta I hat and minus theta dot sine theta j hat. Now if I factor minus theta dot, the remaining is just r hat, cosine theta I hat plus, so therefore it's equal to minus theta dot r hat. So therefore this thing is equal to minus theta dot r hat. Now let's put everything together. A is equal to r double dot. I'm going to put all the coefficients of r hat in one single place. So I have r double dot here, then I have minus theta dot, and actually I have r theta dot minus, so it's basically r theta dot square r hat plus, now put every coefficient of theta hat in one place, so r dot theta hat, and the same thing here, so therefore there are two of them, r dot theta dot, and this thing here plus r theta double dot theta hat. And this is an expression for acceleration. Now again, if I write Newton's second law, F equals ma, I can always break this equation into the two components. So usually this is called centripetal force, Fr, or radial force, sometimes it is called. It's equal to MAR, and AR is simply that. It's equal to M R double dot minus R theta dot square. And the other component is usually called tangential, so it's F theta equals M A theta, and A theta is that. It's equal to M R theta double dot plus 2 R dot theta dot. Now there is a class of very important motion called motion on circle or circular motion. For that case, R dot equal to R double dot equal to 0. That means the particle is moving on a circle, and a circle always have the same radius, so that's why we can put that equal to 0. Then for that case, R double dot is just 0, and then Fr is minus Mr R theta dot square, and F theta is Mr theta double dot, Mr theta double dot. In the next videos, I will use these two equations to solve some circular motion problems. Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.